Good day, students. Today we're going to look at a couple more examples in your solutions of your practice exercises. This is in chapter 6 on page 21 in particular. This deals again with exponents, and if you watched the last few solution videos, it's all been about rules of exponents, and again now we're looking at fractions. So we have rational expressions with exponents on the outside, and the rule is very simple. If you have a fraction, something like this, raised to a power of a third exponent, then it affects both the numerator and denominator. The long way is you would of course break it up to numerator and then denominator, then use your exponent rule. 4 times 2 is 8, y times 3 times 4 is 12. Now we skip this step, right? We don't need to do that step, so we just multiply in on both the numerator and denominator using the same rule as we've used before. If you had x to the 4 y all squared, you know you multiply in on both exponents. That's understood to be a 1 there, so this would be x to the 8y squared. So we're going to skip this step altogether, aren't we? We don't need to do that. Now again, anything with no exponent is understood to have an exponent of 1, and I encourage you in any example you do to put in that 1. I look at here and I see a 5 here on the m, a 5 on the n, a 2 on the x, but nothing on the 5, and it has its own exponent. So I'm going to write that in. Whoops, it doesn't look very clear there, but I'm going to write that in as 1. Okay, so there you have. Now, whoops, what happened there? Let's get rid of that. Okay, so there we have now every base has an exponent, and that's important. Now you multiply in. Now you see the negative sign in front. Okay, this sometimes causes students difficulty. Now the negative can either go in front and stay in front, okay, or you can actually put it in the numerator or put it in the denominator. You can't put it in both, but to me I would leave it out in front because it's negative to a odd power, which is going to make our expression negative as well. So this would be just negative. Now 5 times 3, so it's m to the 15. 5 times 3 again, n to the 15. And then on bottom, of course, we get what? We get 3 times 1 down here. See that? So it's going to be 5 to the power of 3, right? And then 3 times 2 for the x would be x to the power of 6. Now, do we leave our answer like that? Do we simplify any further? Right? Certainly depends on what your teacher is asking you to do, but I would expand this 5 cubed. Right? Always expand your numbers. So, and the negative can go in front again. Doesn't have to go up with the numerator. Just leave it in front. So it'll be m to the 15, n to the 15, and then 5 cubed is 125. So I usually do expand the numbers. I think your teachers would expect you to do that as well, right? So there's a solution for that one. Okay, so that's done. Let's look at now f. Same idea. Now always I check. First thing I always do is make sure everything is multiplied inside, which it is, or divided, and I have an exponent on every base. And again, there's no exponent on the 2, is there? On the negative 2, so I'm going to put that in. Now you can leave the negative on the 2, that's fine, and we can expand it that way. So the top becomes, again using that rule, x to the 3 times 5, 15, right? You just multiply in, so 3 times 5 right there, see it? Then you got y to the 4 times 5, which is 20. Negative 2, I'm going to leave it in brackets, to the power of 5. Now how did I get 5? 5 times 1 right there. The exponent's understood to be 1. I wrote it in. X to the power of 5 times 2 is 10, and y to the 15. Now again, expand your numbers is a good way to simplify. So negative 2 to the power of 5 is negative 32. And again, anytime you're uncertain, step over to the calculator and just double check things. So negative 2, see that in brackets, to the power of 5, and I'm going to see what that is, and indeed it is negative 32. Now simplifying, now we're back to simplifying like bases. Look what we have here. See that? We got x to the 15 over x to the 10. Do you see it? I'll circle it one more time. See it? X to the 10. So we've got this, right? X to the 15 over x to the 10. And of course when you divide like bases you subtract exponents. So that's going to give me what? It's going to give me x to the 5 on top. There's more x's on top, right? So put your where the higher number is. So x to the 5. And I'm sure you can see now y to the 20 over y to the 15. See it there? What's that going to give you? Again, we subtract and we get y to the 5 on top. And I don't think we can do anything else. Let's have a look. No other simplifying. So there's your final answer for F as well. So there's a couple of examples. Hopefully that helps. That's it for now.